All right, so who has not yet heard about the air quality competition? Make this really quick. Hey, only one person. Nick, you've done an excellent job. Yeah, you're getting a lot better. Quick recap. We're spending the entire summer working on an air quality competition. You can go out to bigdatautah.org and find out most of the information on that page. Every Friday at noon, we meet at Leonardo, talk about the data sets we're working on, the competition pieces, what we're learning. We'll have talking sessions in there and learning how to do different scripts. Matt's going to tell us all about stuff tonight, too, to help us out with that. The basic idea behind the air quality competition is that we're spending the entire summer cooperatively working together to collect and find data about air quality, and then towards the end of the summer, towards the August, we break into teams and actually compete about it. Okay, so make sure that's clear to everybody. There's not really much of a competition until the end of the summer. We are going to spend a lot of our time working together during the whole summer, learning how to extract data, transform it, get it ready, and get it up on civic data sites so that we can all use it for the competition later on. Competition's goal being to improve the air quality of Utah. That makes sense, everybody? Like I said, you can find out all the information here. Matt, if you'll scroll down for me, you'll see right on the right-hand side of the page, right there, there's a subscribe to the mailing list. Please subscribe. It's great that you RSVP on Meetup and all of the stuff like that, but we're sending out weekly reminders through this mailing list. Okay, so please subscribe. You're not going to get a ton of spam out of this. You're going to get a once a week letting you know exactly what happened last week, what's going to happen the next week. So you know all the meetings and all the agenda items that are there. We promote everything as well through Meetup, but we'd love to see everybody on that list and kind of know that you're engaged, and that's the list we're working from. So let's see. Questions on that? Anything we got concerns? Yes?
So is this separate for the competition or just for the...
It's basically for the whole thing.
For
Yes. This is the page you want to go to find out anything about the competition, everything going on. This is kind of our main site to find everything. www.bigdatautah.org. We're working on JIRA tasks right now, too. We're going to have a JIRA board set up. This should be ready on Friday, where we'll have tasks in there that say, okay, here's a website to go to. Go find the data off of this and collect it, and then here's how to modify it. Those sort of things will all be in there. We'll also have training videos. All the videos we're recording right now are all on the Google account. They'll all be listed on here so that you can go and watch those at any time to learn more about what you need to do for the air quality competition. Make sense to everybody? Did I miss anything? Trying to think if I missed anything. Yes?
So on that, on the JIRA task, when folks, for those of us who aren't very advanced, when they do come up with, I guess, a program or something to clean up the data, will they be posting that as well?
Yes. All the code, all the data sets are 100% open source. We've got GitHub pages from each of our individual people. We're working on putting that under one org, Big Data Utah, and then they'll all show up inside there. We'll have a link on here that says, here's where all the code is. So there will be GitHub repositories for all the code that's there. As soon as that starts getting more and more, you know, as soon as we get a couple weeks in, we're going to have some of those. We don't have a ton right now, but as soon as we do, that's where they'll show up. And exactly on what they do, how they do it, the Python scripts, the whatever scripts they use, they will all be sitting there in those GitHub repositories.
Great, thanks.
That answers the question. So by the end, and even during the competition phase, all code that's done in the competition must be open source. So it's nothing that can be proprietary. It has to be given back to the community for everything you do. All right? All right, any other questions? Okay, I'll let Matt get started. He's going to introduce himself. He's been an extreme help with all of this, though. We love Matt to death. And yeah, you can talk about who bought the pizza and everything today. Like I said, all of these meetings should be broadcast through Google Hangouts. So if you follow the Utah Geek Events account, that's the one that mentioned these things today, and there's a link to it on this page. If you follow that account, you'll see all of these events coming up as they come up, okay? Oh, looks like we have some more people, so welcome. Another second.
Come on in, there's pizza over here. Can everyone hear me okay? Okay. So I'm Matt Davies. I actually started this little endeavor with Nick years ago, and then I had to move away, and then I'm back again, and you know, you guys are graced with my presence. So I work for a company called Miller and Associates. We're based out of Dallas, Texas. I'm a consultant. for them, work for some very large companies. A few of our friends are located here. But we really love our customers. We really love what we do. It's, I've worked at some great places in the past. Tint here in the Valley, Symantec, Nike up in Oregon, and this is my favorite one so far. So what I wanted to share with you guys is we're opening up a practice here in the Salt Lake area. So we're always looking for people, all disciplines, data scientists, coders, PMs, everything. So if you have any questions, just let me know. That's the end of that spiel. Okay, now let's see if we can't make PowerPoint behave. Here we go. So when Nick and I approached Nick and said, hey, there's a definite need for getting the word out about big data in this area. This is in the very early days, relatively speaking. This is in, I think, 2010. So when we started, Tint was the biggest user of Hadoop in the Valley that I'm aware of at the time. I know Bob Jones probably fight me on that with Zion Spain. But we did completely different things. Pig started off being the workhorse of what we did and the workhorse of Hadoop. It is the thing that's been around the most outside of the pure Java map reduce. It's a thing that I cut my teeth on. I love it. There are a lot of other things out there that are more shiny and that are fun and can really blow your minds. But I'm going to talk about Pig and can it really be cool again? That's one of the reasons why I say, can I wear lipstick? See if this is going to work. Nope. So today we're going to talk a little bit about the introduction, data lake, why Pig. Last week at the Leonardo, you guys should have, if you're on the mailing list, you would have gotten a link to a presentation that Alton did about the air quality of data. Well, I'm going to do the same thing in Pig, show you how that works, and you can go and compare, contrast and compare. And then finally, Netflix put out an awesome tool called Lipstick itself. We'll talk about that and end with some QA. This will be posted. If you have any questions that come up or whatever, I really like talking about this stuff. I really like socializing it and publishing it. That's how to get a hold of me. The sites that I'm a part of, and my email and LinkedIn. Anyone know what this is a picture of? A lake. Specific lake? It's in Utah.
That's not real. It's,
No.
Jordan now.
No, it's up north. I'll tell you. It's actually a reservoir. It's Pineview Reservoir.
oh, fine.
Okay, so I come from up north. This is my favorite place to be. I want to hope that's me out there on the lake, but it's probably not. But that's a little bit about me. I love being on the outdoors. Hopefully, if you come work with me, we can have some company meetings out on the lake. But I can't guarantee that. Data lake. Who's heard of what a data lake is? Anybody? No?
Can we guess?
Sure.
It's just the pooling of all of your data.
Mm-hmm. That's pretty much it. Yeah. And along with that, it's kind of like the term big data itself, which is overused. There are a lot of meanings. Or cloud is another one that's used and has a lot of different meanings to people. When I use it in the context of that. It's a common collection, a foundation where all the data is stored and can be accessed. So if you're a data head, what you really like, what keeps you up is this. You wish you had access to this. This is a Google data center. And you're thinking, starting off when you're maybe in college, you had one of these 2U server, and you're thinking, oh, that's really cool. I have a lot of power. I have a lot of storage. How in the world do I get it to use the resources of this one and this one and this one and all the way down the rack? And more importantly, okay, that's fun as an academic exercise, but as a business, how do I make money doing it? Why would I invest money in this? And that's the other part of the thing that I like doing as an architect, saying, going to the C-levels or the directors and saying, this is why you should invest in this technology. It's an investment. It's not just playtime. So this is what you want. This is what you get. You need to go out and you need to have a good definition of where everything stands, logical, physical, how everything interacts. As you can see here, you've got your Hadoop cluster. It sits separately from BIs, separately from all your web stuff. It's not going to overtake the world. Pig will play a foundation in this, but it will not overtake the world. As you saw with that server, I remember back in the day when 64K was the most important number. I just picked random numbers, 48 gigs, terabytes, petabytes. Your data's growing, and conventional processing can't keep up. There was a company I went to go meet with that was throwing money at a problem by buying Netezza boxes. Those are pretty pricey. And they were just buying time before they eventually exhausted their money. And they knew they'd have to go to Hadoop. That's a lot of money. That's a lot of data. And they were just pounding that to death. Even though there's a lot of data, it's not the size of the data that matters, but it's the value of the data that's within it. There's the idea that you capture everything regardless of present value of it. Maybe there's a future value of it. But how do you tease out what that future value is? And how do you actually access the petabytes of data that you may have under your control? I want to talk a little bit about something that I just got done doing. I just did an implementation for a large luxury retailer, putting in the foundational Hadoop cluster. This would be, at first, was going to take over the EDW. And then we decided it's not an operational system, it's an analytical system. The purpose of it was to gain better insight as to what or who a customer was. You have lots of data feeds coming in. They all use different identifiers. And how do you match up all these data feeds to provide a consistent view of what a customer is? Some people call it one view, 360, or there's a lot of terms for it, but that's the problem we were trying to crack. This is not from that project because I can't show you our graphs, but this is one similar out there. Imagine a graph out there where it looks like a fireworks. You have all these different edges, all the nodes, and then you have a few pieces that do transition in between them. Our particular one that we did had 11 billion of these edges and several hundred million vertices. That crushed all conventional processing. There was no way we could do that. We started off with a platform provider in the cloud, and they forced us to go down the route of using a shiny system named Hive, because that solves everything in the world. And it failed miserably. It's good at what it does, but it's not the end-all be-all. It could not do this graph-based approach. One of the things that we had to do a lot, and very common, was something called self-joins. You join against yourself on a big table. You probably do that in your existing. Hive could not do that. And even when we were doing joins on something that scale, it exhausted memory, and the optimizers fought against us. We reverted back to Pig, and were able to solve this. Back to Pig and why it's really amazing. This problem in our early phases was taking greater than 2 weeks on a cluster to compute. Full bore, 100% utilization, 2 weeks. By some optimizations and clever usage of Pig, we were able to bring that down to 28 hours. That's still a lot of time of cluster for one build. That just tells you the amount of, if you get really good at Pig and know what it's doing and really optimize it, you can shave off tremendous amounts of time and resources. And now instead of processing every 2 weeks, you can process almost every day. And next generation of that, you'll actually be able to go faster. This is something I got out of Forbes I thought was pretty cool. The data lake dream is a place where data-centered architecture, where silos are minimized and processing happens with little friction in a scalable distributed environment. Applications are no longer islands and exist within the data cloud, taking advantage of high bandwidth access to data and scalable computing resource. Data itself is no longer constrained by initial schema decisions and can be exploited more freely by the enterprise. That's a lofty goal. Traditionally, when you load data in, it comes in a rigid schema. Have you guys heard of schema evolution? Anybody? Okay, I can tell you an example. Omniture. Who uses Omniture here? Anybody? One. Has your schema or the variables that you guys use or the meanings of those variables ever changed over time? Absolutely. That's a very common situation. How do you get something you've already loaded in, maybe you've already spent weeks processing data, to sit at rest, load new data in, and have them automatically work together? That's schema migration, where you can actually store something new using the same tables and get it to work together. This is a dream. It often starts by, over here on the left, you have your existing data warehouse. The red dots are applications and the users. You may have something connected to the data warehouse, connected to a user. You may have something that is completely self-contained off in the world. You then move into the second step, where you introduce Hadoop. Some applications use Hadoop. It exists side by side with the data warehouse. Third iteration, Hadoop becomes more central. You introduce some analytics to within the Hadoop ecosystem to take advantage of the data that's growing within Hadoop. You can see it's not meant to take over the data warehouse, though you could. But this is the sweet spot, I think, and lots of applications begin to start to use it. And then finally, the dream of this author at Forbes was that the applications actually reside within Hadoop. This means that anything that's out here, maybe it's a C++ app, maybe it's Perl, maybe it's some legacy system, often gets rewritten and pulled in to do the massive data crunch, taking advantage of a common data store. Data warehouse still exists.
I've got a question on that.
Yeah.
When you say a data warehouse, it doesn't take over the full job of a data warehouse. What pieces does it not take over?
That's a great question. So I often split that in my own mind in terms of an operational versus an analytical system. An operational system would have like maybe a financial system where you have very tight constraints, audit capabilities, the read-write, things that Oracle does really, really well. They make their money doing that. But what they do really poorly is the storage of large amounts of data on the cheap and crunching that large amounts of data on the cheap. So you can move it back and forth between the two. And in fact, a pattern that I'm starting to see out there is connectors. One of the things that we do, that my company specializes in, is the data warehouse. We have people that do Nativa, that do Vertica, that do Oracle. And we're building the expertise to connect the systems so they can actually share and do a deep pull out of Hadoop into these systems and vice versa, pushing back and forth. Hadoop becomes the system of record for a lot of the data, and it's pulled into the data warehouse where you may have legacy systems that are still connected to it.
When you mentioned the applications connecting to Hadoop, or the goal of that, are you talking about applications that are map and or reduce capable then, or?
Maybe there's Spark, maybe
okay.
there's, I mean, there's
okay, so you mean
anything that's in the Hadoop ecosystem.
Got it.
So there could be a lot out there. Again, it's a dream. There are a lot of barriers here, and it's not just something that everyone's doing. You take baby steps. A smart enterprise is not going to just say we're going to bite off that right to begin with. They're going to go down and they're going to take baby steps to get there, minimizing their risk and their exposure. Yeah, excellent question. One of the really cool things that are starting to come out are the connectors into Hadoop. So existing systems using JDBC, NFS, whatever, can connect right in. Or there's actually some APIs that people have written that connect right in and pull data out, in and out. So that's what I was talking about. So you have HDFS, Hive tables. Impala is something that's specific to Cloudera. That's if you haven't used it or experimented with it, it's amazing. It's got a lot of works on it too. So I wouldn't put it to production myself yet, but something that would take Hive, take 10, 15 minutes to create query and come back, you can get it on the order of 10 to 15 seconds. It's that big a difference. Same data. There's some catches, and that Impala doesn't support all the data structures that Hive does. So if you have complex data structures, you won't get them. Same thing with Pig. If you're trying to connect Pig up to Hive, which we'll talk about a little bit later today, there are data structures that are not quite supported, but you can find workarounds for them.
Have you played with any of the Google stuff like BigQuery or Dremel and that stuff?
No, I haven't.
Okay.
I'm more in the Hadoop ecosystem.
Okay.
What was the question?
Oh, the question was, have I played with anything from the Google stack? BigQuery.
Dremel. I mean, things that maybe accomplish similar goals, but
A lot of these
Hadoop.
things are modeled after everything that Google's produced, right? So, yes, right.
Do you put drill somewhere in this space as well?
Drills?
Drill.
I haven't used drill. The question was, do we put drill somewhere in this space? And I haven't used drill. I don't know. What is it?
It's like a SQL layer on top of accessing HTML.
You could? Good. You could absolutely put this somewhere in this. So the dream, as we're talking about, is whatever connector, and there's going to be new technologies coming out there all the time. It's hard to keep up with them all. But the dream is to capture and get at the data lake. And I'm going to specifically focus on Pig. Why Pig? When I was at Tint, there was a guy there that loved to talk about hammers. Everything was a hammer to him. And so I've actually really liked that, because if you're familiar with doing hardcore Hadoop, it's really heavy lifting and really heavy hitting. It's not something that our Python friends or our Ruby guys, they hate it. They're like, this is too structured, it's too hard, it's not easy. But there are different sized hammers to accomplish different things. And Java MapReduce is a tool. Pig, all the streaming, Hadoop ignorant, I use that loosely, meaning legacy systems, anything that do not understand the Hadoop API, and Hive. We did a competition once to see if Pig was that much slower than Java MapReduce. What do you guys think? What was the result?
So
It was slower, but not that much, maybe 10%. This was 3 years ago. But the investment to write the Pig script was very, very little. The investment to write the Java MapReduce was very, very high. And the cost to maintain the Java MapReduce is very, very high. So that's one of the things I like to think about too is, sure, it's cool. It'll put hair on your chest to write Java MapReduce. But it's something that the people that come after you will probably hate. Pig, it's come a long ways. It has some really, really cool things associated with that. Streaming, again, I haven't used that. The shops I've been a part of are all Java shops, and so Pig speaks to them. They're not Python, not Ruby shops. And then the Hadoop ignorant, we find ways to connect the systems, and we can talk about those a little bit later. Hive. Hive is an excellent tool, don't get me wrong. The business analysts love Hive because it's got a SQL-like interface. And they don't have to be trained on a procedural language like Pig or Java. So it does the same thing, but how do you connect the two? And that's really what we're going to get at today. So can you make this workhorse look attractive? Absolutely, you can make it look really, really shiny. Especially in what I do, I'm always considering the cost to develop as well as the cost to maintain. That's something that we all as a community need to embrace. It's very easy to go out there and say, this is the cool, new, shiny thing. Let's go tackle that and bring that into the enterprise. You have technology sprawl that someone then has to come in and manage. It becomes very, very expensive, and then the project fails because they run out of money, and then you're left with a bad taste in your mouth. That's not something I want people to endure. So why pig? It's got a procedural syntax. It's something very that most classically trained IS or CS people can readily understand. It's very easy to look at and kind of see what's going on. It does have some quirks in the syntax, like most languages. Something that you can do in about 4 lines of pig code. I've seen hive queries that are multi-page, where you're doing embedded selects. It becomes very, very hard to maintain because you can't figure out where in the world those curly braces are. So that's something that's easy there. It has some great optimizers. Actually, I say good. Sometimes the optimizers will fight you. This is a list of the ones that they put on the pig site, the pig Latin site from Apache. You can turn on and on each one of these things, and it tries to do the best thing possible by turning on and using these as appropriate. You don't have to explicitly use these. I say sometimes they fight you. Sometimes I've found that, particularly if I'm writing a UDF, a user-defined function, that these optimizers don't quite know how to handle it, and they'll fight me, and you'll have to turn it off. Some of these are newer, and they're not quite baked for all use cases, so you might have to just turn them off. Automatic data pipeline management. What I mean by this is, if you have ever developed in SQL or Hive, you have to manage all the tables. You're going to create a query, it's going to dump to a table. Create another query, pull out of that table, and go somewhere else. In Pig, I can create a line of code that produces a data set. It's stored in memory. It's actually managed by the Hadoop system. And then it's funneled off to the next statement. And it's automatically done. I don't have to do anything. If the Pig script blows up, the data is erased. I don't have to do any cleanup. If I want to keep it around, I can keep it around. If I want to inspect it, I can inspect it. I can see everything. This turns out to be actually a very powerful tool as you develop complex Pig scripts. These are things more than just the load and dump. This is load, transform, join, filter, all those kinds of things. You're going to want to actually look at that data as it's in transit, what it looks like at the individual steps. Hive, that becomes very difficult. The next thing, it's easily extendable. Java, Python, Python, Ruby, Groovy is a newer one. You can, on interviews, people ask me, have you ever used Pig before? I'm always amazed when they don't ask the question, have you ever used UDFs? If you've ever written a Pig script and you have never used a UDF, you're not pushing it to its limits. It's got a lot of features, but it doesn't solve all problems in the world. Good use case of this. This client wanted to build this clustering this graph algorithm, but they had their baseline written in MATLAB. And they wanted to be able to do apples-to-apples comparison between the two output results. So we wrote a UDF. They actually interacted with a Fortran library on the system, did the exact same linear algebra so they could do apples-to-apples comparison. That's not possible using the Pig code that comes with the system. Actually doesn't do a lot of linear algebra at all. Has a lot of aggregate, eval, filter, and load store funcs. What that means is if I want to create something new, particularly one that's easy to conceptualize is the load and store, I want to connect it to a new data source. And something has not been written yet. I can actually create my own ways to go out and fetch data and store data. It becomes really, really powerful. There are a lot of connectors now out there, so before you go down that road, take a look and see what's out there. Algebraic and accumulator interfaces. These are extremely powerful in that in the map-reduce paradigm, you have the map phase, and then a reduce phase. And between the two, you can actually shuffle a lot of data and then have to sort a lot of data, right? That actually takes a lot of time in some of these bigger data sets. So there's a step called the combiner. You guys heard of a combiner? You guys know what it does? Yeah, if you want to. Oh, I caught you eating. What's a combiner?
Data integration.
Okay. But in the map-reduce paradigm.
After showing the summarize the transaction. So
Yeah. Okay, so a good example, in the classic word count example, I take a chunk of data in one mapper, and I want to count the number of words. So what it does, and you typically do, is you just emit a 1 for every word that you see. But if I take a document that has maybe 1 trillion words, just to make this really interesting, and then I have 1,000 mappers, each one of those takes 1,000 words. You know, I've got a bunch of ones that need to be shuffled around and then sorted. How do you sort ones? Well, you know, it's like a know-all. They're all one. But you still have to move the data around. So what the combiner does, it says for each mapper, before you send it along, collapse it down and then do the summary right then and there. We're going to do an addition step right there. So these algebraic functions are functions that can be decomposed into multiple steps. The accumulators, they deal with chunks of data rather than individual pieces of data coming in. And these are both ways to speed up the system. And you can use these kinds of tools within your pig code. Testable. Okay. I know we're all cowboys here, or at least down in Texas we're all cowboys. But in the real world, when you're on call and you're up at night, you want to have some level of assurance that you'll be able to sleep. Pig gives you that. You have easy ways to test your code. You can do a canary pattern, you know, send through some data, see what it comes out with. Also, if you were to happen to have a continuous integration environment, you can actually test your pig code as it stands. Pull in pig, do all the native functions, and then see that it produces the correct result. That's pretty powerful. Lazy evaluation. That means as each statement within the pig line, pig file, is only evaluated when it has to be evaluated. And we can see what that does for us later in the examples, but what it does is it creates an execution plan. It looks for 4 things: a dump, an explain, an illustrate, or a store at the very end. And then it traces backwards and see what does it have to execute to get to that data set. Yes?
A quick question about the testability.
Yes.
Is there like a level of abstraction that you can mock up, like HDFS locations or hive locations that you can do?
Absolutely. So the question was, can you mock up some of these abstractions in the Hadoop ecosystem? Yes, there are things called pig unit that does the pig code. There's MR unit that does MapReduce. There's a mini DFS cluster that you can spin up an HDFS in whatever your CI system. You can actually integrate with all that. I haven't tried Hive, so I can't speak to that, but it's actually really cool. When I was writing these things for my client, I actually spun up a mini DFS as part of the unit test before we ship it out, execute all the code, make sure that it works, and that way I sleep better at night, knowing that works. Great question. Anything else before I move on? I will show you some code here in just a minute, but I'm just telling you about the virtues. Grunt shell. So in the early days, they call it the grunt shell because it didn't have, it wasn't even worth calling the oink shell. It had very little functionality. These days, it's like the IRV for Ruby. It's the interactive way of talking with pig. You can put in a statement, and then you can see the results immediately. You can go step by step. So instead of executing 10, you can go 1 by 1, and you can take a look at the data. If you mess up on the syntax, type it in again, and it resets, kind of thing. Very, very powerful. Some more things. It has data types. This is really powerful in that it allows you to do early error detection. In the big data world, you often hear of typeless or schemaless code that we want to address. That's great and all, but if anyone's ever done JavaScript, you know that maybe it's an int, maybe it's a string, maybe it's double. I don't know, but until it evals, it's all happy. With data types, you know immediately if you've got a problem. Just by the way, if you don't define the data type, it assumes everything's a double. And if you're familiar with Java, there's a lot of overhead with a double. So cast it appropriately, and then you get a lot of speed up there. A lot of functions. See if this this works correctly.
Oh, wait. There it's back.
Cool.
Oh, maybe we didn't lose it. What were you sharing?
Let's see, screen two. Oh, actually, you go to desktop. It looks like it's done everything. Then we'll have to just close this, close that thing down.
Let's hope that didn't crash. Let's see if that's opposite.
All right. Sorry about that.
We want to make sure you guys can see this again later on, so we apologize for the issue.
Now you really get to see the pretty desktop I have. Is that working before I go on?
Mm-hmm.
Okay. So this is part of the notes in the end of this. There's a reference to this. This is a nice pig cheat sheet. So 12 pages long, covers everything from mathematical functions, eval, string, date, time, bag, tuple, load store, and then finally, for all of us that are trained on SQL, you can see what the equivalent is in pig. That's really powerful.
Jack, can you have this as part of the video presentations and everything else, just one of the resources?
Yeah, it's actually part of the PowerPoint, but it's in there. So as you can see here, it gives you the syntax, and by way of comparison, this is the Apache pig site. So I find it's got a lot of really good information, but I'm looking for something terse, very easy to oh boy, there we go. To understand, just very quick and dirty syntax, and that's what this provides for you. So, highly recommend. Go check that out. UDFs. We're going to talk a lot about UDFs and see how they tell you how to use Python, Jython, Java. Well, they say go somewhere else. Java is a little bit more complicated, and all the mathematical functions that you can get within Pig. It's got a rich language. There are a lot of libraries out there that are already built for it, so chances are you don't have to reinvent the wheel. But so yeah, I really hope that didn't crash again. Diagnostics. There's a lot of log output that's produced. You can see what's going on with your pig script as it's running, and do postmortems if you have to. And then UDFs. Finally, this is kind of the meat. If you're not writing UDFs, I really don't think you're pushing it. You're kind of doing the hello world examples. I'm going to get stoned, but try UDFs. There are a lot of things in Pig that are great. They provide a great foundation, but they're not optimized. For example, if you do a for each, and then you want to iterate over that again, and you want to do another for each, a loop, a nested for each is really, really bad at Pig. So what you do, write a Java UDF or whatever language you want, and that will execute about 1,000 times faster. So that's a big win for you. Some tips and tricks. Project early and often. Projection. You guys, what's projection? What do you guys think it is? What's that? Select. So you're selecting certain fields. So the idea with Pig and Hive and all that is I want to reduce the data set as fast as possible. I want to create a funnel. And then as it goes down that processing funnel, I want to throw out all the data that I don't care about, and I want to only operate on what I want. So if you have to think about the map, sort, shuffle, and reduce, there's a lot of data moving around. Filter early and often. Same kind of idea. Throw out all the data that I don't need. If I'm only interested in Utah data for the air quality competition, throw out all the other states. Data types. Like I was saying earlier, it assumes doubles, that you can go a lot faster. Before you do joins, remove null values. This is often a very big mistake with people. It produces enormous joins. Similar with this, Cartesian products. This is a problem in the SQL world as well. Be aware of Cartesian products. With big data, these become extremely large data sets. I did one of these on accident once and created a ½ petabyte of data just in Cartesian products. Huge. The order of joins in Pig can make a significant difference in the order of the variables can make a significant difference in performance. Often you want to take the smaller data set, join it to the bigger data set. Again, that mortar data will give you the examples of that. And the reason why is it tries to load things into memory. It tries to stream the data across it versus keeping everything in memory. Same concept of swapping. You want to move data in. If it doesn't fit in the RAM, you're swapping in and out. Consider heavy UDF usage. If something's not quite working right, or you're fighting the syntax, try using UDFs. That will really, really help. Also, depending on what kind of shop you are, I mean, maybe you're a Python shop or a Java shop or whatever, you probably have a lot of tooling built around these languages already, a lot of domain expertise. Keep that. Use it to your advantage. That will really, really help you. Limits, especially if you're exploring the data, which I recommend you do, make sure you limit. Don't dump everything. It will speed things up. Say if I want, the traditional sample, take 10 rows and then go to town on 10 rows. See if it works. Then you can manipulate parallelism. This is something that you can do to great advantage. The Pig will do estimations on the way that it does parallelism based on the size of the data set. It will estimate how many mappers or how many reducers it needs to do it. You can force it to use the entire cluster and break the data sets into smaller pieces. So actually you can speed things up. Say you have a file that would only be split into 2 mappers or 2 reducers, but you've got 100 machines. Well, most of them are sitting idle and burning a hole in your pocket, so why not put them to use? You can force it to use the whole machine and solve the problem faster. The other really cool thing that you can do with this, if you're writing a MapReduce job and you're not quite sure why things are taking as long as they are, particularly in reduce phase, you can put an oddball parallel factor on this. This is something I do a lot. Like parallel 500 on this join, parallel 600 on this join. And then by looking at the scheduler, I can say, I've got 500 reducers going right here, so I know exactly where it is in that code. I've got 600 here. I know exactly where it is, so maybe I need to go look at that data. So that's something that you can do. Some more. Step through the execution and inspect sample data. This is just obvious. Don't throw it out there. Don't cowboy it. You'll end up spending more time. Practice the scientific method. You've all heard about this in school. Formulate a hypothesis. What should it look like? What is it looking like? Is it working? Do a test, and then move on. Do this iteratively, and I guarantee you will work a whole lot faster. Something else that I highly recommend on all the loads, and even critical sections where you have kind of a complex data structure, put comments in your code saying, this is the type of data that I expect, a schema, and maybe even a sample line, so I can see what it looks like. That'll help you and the people coming after you kind of understand what's going on in your code. Anti-patterns. If you like pain, be sure to do these. Use nondescript variable names like A. This is all over Apache Pig documentation. I hate it. So if anyone has time, which please let's go out and change it. Use something descript like data events or column A joined with column B or something like that. So as you go through the code, because it's lazily execution, you may create something up here, and forget why it's up there. You may do some work over here a little bit later on and use the very same variable name later on, and you obliterate your data, and it's actually something else. I've seen that a lot. Override variable in successive lines. This is valid code. A equals something, some operation. Next line, A equals some other operation. Very quick to iterate doing something like this. It's very quick to do a proof of concept, but it's absolutely horrible in terms of maintenance. You have 10 lines of A is the variable that you're going to dump or store, and a bunch of different operations. If I want to pick it apart and I want to store particular pieces of data, this is absolutely useless. Absence of comments, that's good common sense there. Camel and snake case, just come up with a convention. Maybe camel means one thing and snake case means something else. Cowboy it and don't test locally. So, who has access to a Hadoop cluster? Okay. You ever seen people saying, I'm going to go develop on the Hadoop cluster. That thing's big. It's awesome. I'm going to use it. And then what happens is the developers go in and they take over the cluster and production jobs go away. To tell you the truth, this laptop is your best ally. You've got enough power in this thing to execute and test your code before spending $1 million on a cluster. Test it locally, test it with sample data, use the good testing methodologies. It'll help. Don't capitalize keywords. So there are the keywords, the reserved words in PIG, like load is one of them. So that should be self-explanatory. PIG has a unique problem in that being open source, there are a lot of people that contributed the functions that work both upper and lowercase, like load lowercase and load uppercase, behave the same. There are some functions that only work uppercase. And you'll be finding yourself, if you're not following this, you'll say, why in the heck is my script failing? This is good syntax. An example is count_*. Must be uppercase. All the others, a lot of the others can be lowercase or upper. Leaving cruft in your scripts, as you're developing, you may comment something out, and it's just left, and everyone's wondering, is this something important? Again, common coding practices, get rid of the junk, let Subversion or Git or whatever handle the history for you. You don't need to store it if you don't need it. Throwing away key data. For example, if you're loading in data, Omniture being a good example of this, it doesn't meet some criteria. A common practice out there is to actually ignore it. Well, what if that data is some financial transaction data that really goes important into some model that you're building, and you end up throwing out 80% of your data and not even knowing it? That data that you're throwing away, store it off somewhere. build some alert structures around it, saying if this file exists and it's non-zero, send somebody a tickle email. Go take a look at it. This is something I learned. We were building this graph, and we had a particular structure that was connected that had about 80 million events. Huge cluster. Because it didn't fit within our criteria, we just threw it out. Well, that happened to be the cluster that contained all the really important people's data. They were wondering, I just paid a lot of money for this system. Why isn't my data in the results? It took me a long time to figure out, well, we didn't log it, and we should have caught that right from the beginning. Data will evolve and will not fit your conventions now, so this is something that will save you pain. If marketing says I have a new schema for Omniture, and they shove it, and Omniture all of a sudden starts sending new files your way, and it breaks, hopefully you'd notice something like that. Maybe you built it so it's a little dynamic, but maybe that field just doesn't exist anymore. You got a problem. Don't use variables if you like pain. Use magic numbers. I can show you what that's all about too. And then don't use the correct data types. Yes?
Can you take a second and just mention that if somebody wants to come back in later and talk about different sections of the presentation, maybe go in a little bit deeper, maybe explain certain things, they can come back and do that. That's part of our...
Yeah, absolutely. Yeah, anytime you guys have questions, now or in the future, please come back. If you got a question here tonight, bring it up. If it comes to mind later, there's Google Groups. Use that, or you've got my email. I prefer it's on Google Groups so everyone can take advantage of that knowledge. Yeah.
And don't be afraid to ask. We've designed this so that if you don't know what MapReduce is, we want somebody to ask that question so that we can put up a resource about how to access MapReduce or how to work with anything else, right?
So let's put concrete examples around this. This is something that hopefully is helpful. So this is all included. It's actually out on GitHub right now. You can get it. Nondescript variable names. A equals load file. B equals filter A by E equals some value. I see that a lot. What the heck is A, what the heck is B, and what the heck is E? Well, knowing the syntax, I know E must be part of the schema of whatever's in file. But maybe you have another line E later on, so how do you know what E is actually referring to? Please avoid that. That's very, very poor code. Overriding variables in successive lines. So this is an example of that. You're basically resetting the value of A later on. So I can't get at that second line very easily, the filter operation. I'd actually have to stop it and store the data there. Whereas, I prefer having all my stores at the bottom of the file. I have one place that's the exit criteria. That pattern does not support this type of programming. Absence of comments, well, it's kind of hard to show, but a bunch of code. Camel and snake case. I see this a lot, where you have snake and camel case. Yeah, it's a pet peeve of mine, but probably won't kill you, but it'll certainly save you some time. Cowboy, yeah, you know who you are. Capitalizing keywords. So this is an example. This is valid syntax. A equals load file. A, and then, using the same example, A equals filter A by E. The reserved keywords in this would be load, filter, by, limit, for each, and generate. So make it a good practice to capitalize those, to call attention that they are. A good pig programmer is going to know what those are, but let's help out those around us and call it to their attention. Leaving cruft in scripts. You see this a lot, especially as you're developing code. You're trying certain things out. This is something I do all the time, where I want to load something in. Maybe I want to do an immediate filter. So I'm filtering early, filtering often, so my development goes faster. Maybe I want to do a limit. So that's fine. That's great. Use it, but maybe use descriptive variables. That's something that's different. But before you commit it and go to production, get rid of those lines. Because someone that comes in later, or even you, a month later, is going to say, well, what was the rationale behind that? Why did I do that? And you may not remember. You may not be around to ask, especially in the middle of the night as production support is saying, why did this fail? Yeah, so a good example of this is the second from last line is, I had a for each and I did a projection and I wanted E, F, G, H, and I, but in the actual uncommented code I only want E. So which is it? Which one did I want? Was there a reason behind it? I don't know, but get rid of it if you don't need it. Throwing away key data. So this is a good example. I'm loading in some data. I'm doing a count on the number of tuples in there. And then I'm going to filter. I'm going to say the good records are the ones where the tuple count matches a specified value. You guys know what tuples are, by the way? Sure.
It's like a Python tuple.
What's that?
If it's like a Python tuple, then yeah. It's just
Tuple's a tuple. Yep. Yeah. Tuple's just a bunch of values, right?
It's not a triple.
Yeah. Well, tuples can be arbitrary lengths. They can be, 1 to 100. They're just in Pig. They're going to be in parentheses. You'll see them, 1, 2, 3. Bags can contain lists of tuples or other data structures. So bags contain tuples. This converts everything to a bag, and we're going to count. And we're going to convert to tuples, and then we're going to count the number of tuples. It's just basically a way of saying count the number of elements in an array.
That is specific then to Pig. That particular use tuple, right?
Tuple is a common computer science term.
Okay, so I haven't encountered it often enough to be familiar with it.
Yeah, tuples used a lot in terms of just a collection of values.
Okay, so it's not like an array or
you can think of it as an array.
Matrix.
It can be a set.
What's that?
It can be a set.
Yeah, it could be a set, an array,
Or
a list, or something like that, right?
All right.
But the main criteria is that it's just that one set. A bag could contain multiple sets. So if I were to create a model maybe of an array, a multidimensional array, I would create a bag with a set of tuples where maybe one tuple is row 1, another tuple is row 2, something like that. Okay? So again, great questions. Any other questions before I move on? So example back here, I'm throwing away the bad records. Well, maybe the bad records are actually important. I won't know, but do something about them if it makes sense. If it's going to bite you in the butt later on, you better store it somewhere. Not using variables. Good records equals filter by count equals 4. Well, what if your schema changes and I need to go find all occurrences of this particular design, this particular pattern, change 4 to 5. That's just bad practice. Use good common programming practices and make that a variable. An example of a variable would be like the one that's highlighted, file, where you can pass in a parameter to the Pig script that can be centrally updated, and all your code will just flow through. A common practice is to have a driver program, whether it's Ruby, Python, Java, Shell, whatever, pulls in a set of variables, creates the parameters, and fires off the Pig script. Very common pattern. Don't use the correct data types. So down here at the bottom, it's a little hard to see here, but maybe I'm loading some file in that I have a balance, and I'm using an int as an ID. Well, maybe there's a good chance I run out of key space with an int. Maybe it should be a long. Maybe the transaction array comes in as a byte array, but it's really a date time. Just use the right appropriate data types. The second example, the one right underneath it, is it's actually very common in the examples to load something using pig storage is the default, but people often forget the as something, as A, comma B, comma C, comma D. So what it comes in as, in this instance, is a byte array. Everything's converted to a byte array, and you do boxing and unboxing all the time, and hopefully it just works. But often it won't. And because it's lazy execution, meaning it won't eval until it actually needs it, you won't know you have a problem until later on in the script. Any questions on this before I move on?
Yeah, I've got one that is kind of back in the tuple thing.
Okay.
Like in R, you've got an array, and it's one thing, one data type. But a list can be mixed data types.
Mm-hmm.
Is that the similar thing between tuples?
Tuples can contain any data types.
Okay.
You kind of have to know what's in there. That's the problem with this. So, yeah. Good question. Yes?
Sorry I didn't catch, but by strongly typing the execution at that point, is it like not lazy loading at that point? It's loading right then.
No, what it means is if you're doing any operations along the path, it's going to say, I can't do a comparison. A good example of this is a date time. If I'm typecasting up from the beginning, a date time object, I want to do an order by operation. The Yoda time structure, which is the default in some of this stuff, does not do a compare to operation. It doesn't overload that function. So when you're actually doing the execution plan, it'll blow up, say, hey, you need to do something else here. If I were to not cast it at the top, it would say, well, I'll just try it later on, kind of like JavaScript. And then you may spend hours doing some processing only to have it blow up later on. So it'll just save you pain. Good question. Anything else? Okay. Ah, there we go. Well, we were already there. Some demos here. If you're like me, you really like to see what's going on. So I've created a bunch of scripts here. I won't run through them all due to our time, but so here's the traditional hello world. I'm going to load a file called hello-world.txt. So I created a default variable named input with a default value. The power in this is a good good pattern for everyone to follow. Personally, I counsel and do not like to see any variables that are not defaulted in the pig script. What that means is I should be able to run pig and then the file name, and it should just run with a reasonable set of defaults. I shouldn't have to have this massive command line execution of it. It tells me to sample what the data should look like, the values that it supports, and so forth. But I'm going to load it in. I'm going to create a variable named data that's containing a set of fields called text, and I'm just going to dump it. So the next thing I want to show you guys, when I say this computer has all the power of a real cluster, it does. It's running by itself. So what you can do is on the command, can you guys see this? Should I make this any bigger? Try that. Is that big enough for everyone? Something called local mode in pig. Extremely powerful. Instead of shipping off to the cluster to do execution, it keeps it locally. You have all the power, almost all the power there, to run. And it's extremely fast. So I can give it the name of my script, and I can execute. Couple things while this fires off. You can see it's doing all the normal syntax that you'd expect to see. I have not had good luck if your cluster or the machine that you're using is security enabled, meaning it has Kerberos put on it to authenticate yourself to the Hadoop cluster. That doesn't work very well in the versions that I've tried. So local mode doesn't work. So I often create a VM somewhere that does not have security enabled. Make sure there's no PII data, and then I can run fast. Okay. So here's an example of a tuple. It output hello world, right? Okay. So if we go back to, you can see I basically have a hello world.txt. I'm reading in a text file. It's got a space in there. The default behavior for pig storage is tab delimited. So this reads in, another common word would be a token. It tokenizes based on the delimiter, which would be a tab, the default behavior, and it sees one tuple, which is hello world. Whoops. Shoot. There we go. This is getting a little bit more complicated. We're doing a for each generate. You can see I forgot to capitalize for each here. That's going fast. But I'm iterating over the data, and I'm going to generate basically what. Let's start here. Let's take apart the nest. I'm going to do a string split on the text tuple based on a space. I don't want any limit. That's what the 0 specifies. If there's 1,000 spaces, you can tokenize 1,000 times. I'm going to flatten it. Means I'm going to pull it apart of this nested structure. I'm going to have a single tuple, and then I'm going to actually dump it. Local, and then hello. So it gives you a slightly different output. So you can see here, we've tokenized it. The tuple is now hello and world as separate fields within that tuple. And then I added another line. You can see commas are separating the text. We did this based on a space. So this is helpful if you want to tokenize something. What's a little bit harder to deal with here is this is a single tuple with arbitrary length. If I were to do a word count, I could do it, but it's probably not the best way to do it. So let's take a look at hello world2.pig. Now here you can see a little bit more complicated. I've got two different things to show you. The best example is the generate flatten. Let me show you what that does, and then we can uncomment it and show the other one. You can see in a normal cluster, this would take a long time. It's going to spin up a bunch of JVMs. They're all going to take their execution time. This thing could reasonably take 3 to 4 minutes on something very simple like that. So my iteration cycles to develop pig code are dramatically faster this way. So the difference being, this created a list of tuples with each word as an individual tuple. This becomes a really trivial thing to do counting with, or anything else. But you can see that the data structures, you can really start to manipulate the data structures based on how you output the data. Let me show you what this other one, if I don't put in a flatten, it's just going to nest it. It's going to have a couple. So what it's done is it's actually created a bag, which is the curly braces, and within each bag it's got a tuple, a couple tuples. This is probably one of the hardest things that you have to get your brain around in Pig is the concept of bags and tuples, how to pull them apart and how to assemble them. But trust me, it will come. It becomes very powerful. Third example is a term frequency. It's not a true TF-IDF, it's just a term frequency. But I want to count everything and I want to order them and I want to dump it. So let's show you this real quick. We'll get to something that's more interesting. Because this goes into how you load data and how you start to massage the data to make it meaningful. So this is the text from the UHUG front page counting the frequency of the words, V to Hadoop, and so forth. Becomes pretty interesting, but you can see I've got some data in there that will cause some problems. I've got some non-ASCII or non-alpha numeric things in there, like asterisks and a period, a dashed UHUG. Maybe there's multiple occurrences of Hadoop right there. Great catch. So what do? This is an example of the scientific method. I want to do a count like this, and often with big data, there's the expectation that you can't have a reasonable assuredness that it's going to work correctly. Well, sample the data, try and figure out. You will spend the most time massaging your data, more time spending massaging the data than you will building your script. I guarantee that, right? And this is a way to do it. Just take a look at it. Yeah.
Is there a regex filter you can apply to the function?
Sure, you can do regex. Absolutely. The question was, is there a regex filter? And yes, there are regex filters for splitting, and there are certain data manipulations that you can do. I was actually going to show you on the next thing here.
Or is there a better way to filter that out?
Well, let me show you something. That's a great segue. So again, my comment earlier was use UDFs, user-defined functions. If you're not using them, then you're not really putting it to the power. So it's pretty simple to remove punctuation. But what if you have business rules that are more complicated, that need to be kept centrally located? A good Java library would be a good thing. You already have all this money spent building up this ecosystem of code. Why not use the same thing in Hadoop? So that's where UDFs come in. So I've created a class here. You can see it's called Simple Word Cleaner. It's contained in a jar file. I can load the data in. I'm going to tokenize it, do the exact same things as before, and then I'm going to apply this function. This is a custom function called cleaner that's going to go out and it's going to remove the punctuation before and after the word. It won't remove it from the beginning. So it takes a little bit of time. I had some dumps in there. It's not what I was looking for, but let me do this. Oh, there we go. I dumped my check script. So what I did here is I did a frequency count, and then here at the very end, I want to sum everything to make sure it actually sums to 1. That's why I was seeing the 0.999. So within rounding error, I've achieved my 1. So what I need to do is before, if you remember in the script, I had 2 dumps. They were split apart a little bit because I didn't follow my own best practice. It went and it executed a bunch of other code, which is all this other stuff down here. This is all the MapReduce code. But here's the term, the count, and then the relative percentage of this. So as I'm looking through this, this all looks great until I get up here towards Hadoop. I know there was a problem earlier with Hadoop. This actually causes a problem. What's the problem that you might see with this? What's that?
It's not summing them up. I mean, it's keeping them separate.
Yeah. Yeah, that's correct. It's not summing them up, and it's creating separate instances. So by frequency, if I were to do an API, so suppose I'm building an API, and this feeds the API, and I want to know the relative frequency of a word. Depending on how the API works, I'd be shoving in 4 key value pairs with Hadoop and different values, assuming I could do that, assuming they don't collide and they don't clobber each other, right? Now, that's not the correct result. So what do you do? So, what's that? That's correct. So we're moving around where we do the cleaning operation. So let me find it here. There we go. So in the actual tokenization of the data, I've applied the cleaner function there. So before I do any of the grouping, so right here, I'm grouping by token. I've already cleaned up the data. So when I would find all the occurrences of Hadoop, Previously, it would have found Hadoop punctuation mark, and it created separate values to pass into the reducer. This will remove all that, so it collapses down and produce the correct result. So you can see what that does here.
What does your cleaner function do?
It's a great question. So I'll show you that. So just to prove I'm not out in the night here, Hadoop is the correct. It's 8 with the relative frequency there. So that's a great. The question is what does cleaner do? So this is a good time to show you the actual Java UDF. This could consume a lot of time, but just kind of highlight it's a simple. Actually, that's not it. Simple word cleaner. This extends an eval func. So this is a custom evaluation function that I've created. You have the ability to pass in configuration values when you instantiate. So maybe I wanted to do something like pig Latin, right? And I wanted to have a suffix that I wanted to add to everything. I could add that in here very, very easily. I can call it an init, all like normal OO code that supports that. Output schema, this is something you override, very, very powerful. So when you go into the code and you're actually interacting with it, you can do a describe on a a variable name. It'll give you the schema, what it looks like. But if you pass or use UDFs, by default, it doesn't know what the schema coming back is, and it's left to guess. This is how you get around that problem. You tell it what the schema of the output values is, and then it can keep flowing through. I can use the describe and so forth. If it's a char array, I can use char arrays. If it's a double, if it's an int, you can do all your data typing and keep that strongly typed. The exec function is where all the magic happens. This is just a very common pattern to check and make sure it's not null and it actually has some content. And then I've really made a whopper of a line there, but cleaner is just a normal code. So think of you have a jar file with a bunch of libraries out there. It does some common business function. There's nothing special in this. This is all it did is converts to a char array, and I'm going to start from the beginning, find the first alpha numeric, go to the end, and work my way backwards, and then do a substring. Through empirical testing, we found that's actually faster to do, to walk the arrays than to use the native regex function. So to answer your question earlier, when regex is really, really slow, this tends to work really, really fast, because then you get into the int type operations. More importantly, this is testable, right? So I told you before that I expect everything to be tested, right? So here's a unit test. I have my assertions. I'm going to create an input. Run it is just a helper function. It's a common function. I'm going to take an input. I'm going to create an instantiation of this cleaner object. UDF, I'm going to create a tuple to pass in to simulate pig code. I'm going to add the input to that. I'm going to call the exec method. I'm going to get a result, and then I'm just going to pass back a string. So you can see here, hopefully everything runs, build success. I go through and I actually get what I expect to get. So continuous integration environments, my UDFs can actually be tested and maintained. Common coding practices still apply. Okay, while we're on the UDFs, this is another function for a little bit later on. I'll show you. Pretty time. Again, so a date time comes in as a YOTA time. I want to get a particular field from a tuple, convert it to a date object. I need to make sure that it's actually not null. Oftentimes, a common coding error is to not expect nulls, and it will blow up, and you'll waste hours. So check for nulls. And then I do the normal two-string operation. Simple word cleaner DB. Yeah, I'll show you what this one does here in just a minute. Any questions on UDFs so far? I mean, this is really, really fast. I know it's fast as fire hose, but these are all out there. You can get in there and build it. It's all Mavenized. You can try it out and play with it. Yes, question?
It all goes through the JVM, right? Like you can compile it through Java or Python, or it's not like native Python.
You can. You can run native Python. So the question was, does everything go through the JVM? And the answer is it doesn't have to. So think of Hadoop as a processing framework. It's built on Java, but it has calls out to the native operating system. So they support Ruby, Python, Jython, Groovy, anything that runs on the JVM, I'm sure. I haven't specifically seen a Scala kind of thing, but I'm sure someone's figured out how to do that somewhere. Another question I thought I heard? No? Okay. Okay. So the next thing I was going to do is bring you back full circle to the data lake. So this is all great. We're reading in data. We can store data. We can store data into HDFS. But what if I have a bunch of business users that are in Hive? As you're aware, Hive has a different data storage mechanism. It's a completely different part of HDFS, user Hive warehouse, unless you store it somewhere else. So typically, you'd have these silos of data that would exist. Pig users would have their silo, Hive users would have theirs, and to get the two to talk to one another was a really big pain. So to get around this, and I want to put a shout out in case they ever hear, but a couple of my buddies from Cloudera, Madhu and Daniel Rule, really put us onto HCatalog. HCatalog is a way for Pig to go out and get catalog information from Hive, all the metadata associated with Hive. So all the data structures, all the locations of the partitions are all immediately available. There are some gotchas, but largely it works beautifully. So rather than showing you taking time, because it's going to take a long time to actually run. So here's an example. I want to load some data into Hive. And maybe this is part of your ETL process. So I'm going to load some data in using Pig storage. So it's a tab delimited file that I'm expecting. And I want to store it out into HCatalog into a certain partition. So that's a very common use case. I want to store it out somewhere else. Maybe there's some data munging that's going on in the middle. So this gives you the power of Pig, but then allows all your business users to use all the tools they're used to and get at the exact same data. You can see here another common pattern is to build up your variables. Start with a database, a table, create an output, which is a combination of two variables. That way I can easily override a database name, but have the entire same table structure. So if I have a test and a prod, it becomes very easy for me to just do a bunch of create scripts and then just repoint the database and all my code, and then I have a good prod and dev and test environment ready to go. I default the partition to 1, but if it already exists, it's going to blow up. There's nothing I can do about that. That's just Hive. Questions on this? On how that works? I may have actually, yeah. Way to do this is to simple. Is to just give this switch here. Use HCatalog. It's that simple. It will take all the appropriate libraries, put them in the class path, set up everything, and it fires off and interacts with Hive. While this is running, as you can see, it's going to take a little bit longer than the local mode. Some of the gotchas associated with this. If you are interacting with a very large table in Hive, particularly if you have schema evolution going on, it has to go out and merge all these schemas into a consistent view, meaning you have column A, column B, and then maybe the next iteration is column C, creating column A, B, and C. That can take a long time. Just be aware of that. It's not Pig, it's just Hive and Metastore. So the Metastore becomes very, very powerful. See, I should have data there if everything worked correctly. So before there was nothing, now there's something, and I'm using 2 different tools to access and manipulate data. That was awesome for us. We were forced down the road of going Hive before, so we built a lot of tools in Hive, but Hive just crushed under the weight of what we were trying to do, so we moved to Pig. But now Pig can execute, do all the data manipulation, data munging, and our old tools that used Hive all work seamlessly together. We have a consistent environment. This is the first step to the data lake. You have one area to store the data. It's limited by all the limitations of Hive. Which, I mean, I make that sound bad, but it's not bad. It just, there are limitations. But everyone can access the same data. If Hive is Avro-backed, it automatically writes to Avro. If it's an RC file or ORC file, it automatically does all the conversions for you. If you specify to store as compressed, it does all the compression for you. All you have to know is I'm writing to HCatalog, and I'm done from Pig. Very, very powerful. Yes, Nick?
You may have answered this already, but can HCatalog go into a relational database, use SQL, T-SQL, PL/SQL?
No, you use a different tool for that.
Yeah.
HCatalog is just the tool that maintains the metadata for Hive tables. There are newer versions coming out, Hive Catalog 2, which is faster, it's supposed to be more resilient.
What do you mean by resilient?
Well, okay, so we really beat the thing up, right? When I said I used Impala a little bit, it's got some warts on it. So one of the warts with Impala is I want to load some data in. It has new partitions on a particular table using a Pig process. Impala won't know about them because the catalog it creates is completely separate than the Metastore, than the HCatalog. So if I were to re-update the catalog in Impala, it would beat to death, and because it's a single process, it's not HA, it could go down. Okay, so built some, most systems have alerting around this. If it goes down, if the JVM runs out of heap, all the standard things you find in Hadoop. So not something that I'm really worried about, but I've run into these issues. Yeah, here and then there.
Does the Java interface for storage output, the one that HCatalog uses, is that extendable into like other transactional stores like Cassandra or Mongo?
So the question is the HCatalog interface extendable to other data stores like Cassandra or?
Yeah, like so like you were mentioning connectors before. Like,
yep.
Where's the place to do that? I guess.
So the answer to that, where is the place to do that? Is the question. That is the place to do it, but instead of using HCatalog, I would create a custom store function. The store would go out to, I mean, there are Cassandra interfaces all over the place. That's already been done, but let's pick something. Access database format, or actually, Tint. Maybe Logan's going to remember this. We had Tokyo cabinets. Okay, you guys heard of Tokyo cabinets? Well, in-memory database structures, highly performant, but they're very customized. So you create a custom store function that writes the data into that format. Maybe it's a TCP connection, maybe it's UDP, maybe it's just something on a local file system. But instead of storing using HCatalog, you'd store using your UDF, which is a store function. Cool. Question over here.
Oh yeah. Awesome. I was just wondering, how does it? Let's say I have a bunch of data and I want to clean it up for some machine learning or some regressions. I want to use Mount or Spark. Spark is kind of the new darling. Can I control that within Pig itself, or should I write a batch script that calls a Pig script that cleans up the data, loads it where it needs to go, and then I kick off Spark? Or what's the best?
So, you know, Spark's going to have some tools to do things. I think so the question is where to do the cleanup, where does everything fit together, if I'm understanding correctly, right? So my answer is a little nuanced here. I think the answer is, well, where do you want it to end up? So Spark has a nice idea of RDDs, the resilient data stores. Or I think that's RDDs. Yeah, right. So, but I want to store everything in HDFS as part of the data lake. So maybe a common pattern would be load everything in, maybe through PIG as a batch process. Maybe everything comes in at a certain time anyway. And then as real-time updates come in, I want to process using Spark and then shove it back out to HDFS.
He was recommending Zookeeper too.
So Zookeeper would be a coordination mechanism.
Yeah.
So, but yeah, there are a lot of really cool things going on out there with Spark. They say it's the Hadoop killer. I think there's a place for everything, personally.
Is there a reason why RDD is called resilient when it's in memory?
Redundant, I think, is maybe what it is. So the question is why is it called resilient when it's in memory? My understanding is very small, but from my understanding, what it does is it distributes the data across the cluster, so it becomes in memory, but across the cluster. Sharded. Cool. Other questions? Okay, so I took you through UDFs, the term frequency, detecting there's a problem with the term frequency, going through the various steps, how your code can be changed to remove all that. Let's take a quick look at the air quality particulate example. I know we're running long here, but so if you guys remember in this presentation that Alton did, you can go look it on YouTube. He said, all right, let's go get some data from the state. Actually, it's the EPA, and we're going to manipulate it. We're going to kind of take it through its paces and kind of explore. So up here at the top, just kind of lay the groundwork. I have some delimiters that I'm using to read the data in as part of a CSV. The input file, which is a CSV, loaded. It's out on the GitHub account. The only thing I did to it was to remove everything not in Utah, because otherwise it's just too big to shove out there. So that's the only thing I did to manipulate that. And then I have a date format. It's just a string. Maybe it's passed in and overridden for certain functions. I'm going to use something called piggy bank here. It's got a bunch of functions out there that, like I said, there are a bunch of libraries already created for Pig to do a lot of things for you. Pig recently brought in cubing and rollup functions, but previous to that, you actually had to go out to other libraries to bring in those, other things like sliding windows you can do through some of these external libraries. When I said it really helps to get a schema, this is the first line of the CSV. I've got it in the code as I expected. Here's a sample line. As I'm starting to do the data typing, I can see that because this is an Excel file, the state code it looks like a string, but I'm going to actually typecast it as an int. I don't know why they just didn't do that, but I can see where I have doubles for the Latin long, where I have strings, and so forth. This is the most painful part of Pig, is defining the schema. If I were using Hive, I could call in a connector to hcatalog. Somebody's going to have to do the work to define the schema one time. It doesn't auto-discover, but if I were to call into, let me just show you that, because that's something that you'll really like. If I want to read data from Hive, oops. Yeah, reader. This is all I have to do. All I have to do is to load input using hcatloader. What it does is it goes out to Hive, connects to the hcatalog, to the metastore, gets the schema, and then data has a strongly typed schema. I don't have to do any of that extra work. You can see that's very different than here, where I actually had to go through the pain of lining up everything. This actually took a while to line everything up. So in his example, he said, I just want to see a date range. So let's make sure the dates load in correctly, that we're parsing correctly. So the date local, this is a good pattern to follow too, is you're loading data in. Make sure, pick a column maybe towards the end and dump a few examples. Make sure you're not doing the off by 1 or off by 10 error where you think date local is the date, but it's really the number of observations. You didn't miss a field somewhere, right? So this is a good practice to go in and just explore the data a little bit. So I want to find the arithmetic mean for all the cities. So again, I've commented out all the dumps because I didn't want it to execute. But I could go into the cities, group by the city, by the name, and then I can generate the means, and I could dump them. So what that would do is it would say, for Salt Lake City, give me all the arithmetic means of the particulates over this year. So it would be a very long list of numbers. Okay, so maybe I want to do something a little bit more interesting. This is something that our studio did for free for him in his plots, but I have to actually do in Pig. I want to find the min-max average of everything. So great, I've already computed slim city means, so that's here. So my execution path, if I wanted to dump this out, would take slim city means. Well, I need to go evaluate that, so it'd work backwards and see what it needs to get. And you can see here, this is the code, and you guys can see it as well as I can, how I can dump that. But if I want to just, in his example, he said, I just want to look at Salt Lake City, and then over the period of the year, what does it look like? So I'm doing a little trickery here to, because the Yoda time doesn't support the compare to operator, I'm doing something, I'm converting the date to milliseconds, so I can support an order operation. And I'm just going to ignore it, but you could project it out and dump it. Depends on what you want to do. And then I'm going to dump it. So let's run that. So if you remember, you had a nice plot from January to December, and I'm going to do this so you can actually see it. And it had all the ranges. Well, guess what? Pig, I could do ASCII ARP too. It's not as cool as in R, but I can get a good example. This little ASCII ARP is the UDF that I wrote just for this purpose to take the mean for that day and just put out a bunch of asterisks. So it shows the exact same data. As you can see on the beginning and the end of the year, the particulates are high. And then same kind of thing in the middle of the year, July 4th to be exact. I wonder why, but the particulate counts go way up, and then the drop. Yeah. So let's take a look at the 24th. Yeah, not as big. So again, you got to always wonder and say, what's reasonable here? So I'm getting down here to, and I'm just kind of looking for patterns. Your eyes can be good at looking at patterns. But I'm noticing that, I'm expecting an uppercase and a lowercase, like a mixed case. So some of the stations aren't reporting, or they're offline. Or, looks like Hawthorne was offline for a while here. And then later on here, I forget exactly where it is, but I actually had multiple readings. There we go. 12:30 for Rose Park. I had 2 readings for the exact same day, and guess what? They're different. I actually went back to the source data, and there are 2 readings for Rose Park on that day that were different. So that's interesting.
Another times too.
Yeah, and other times. So you kind of got to wonder what's going on. Whoever's collecting this data, they didn't roll up the data correctly themselves. That's what it's telling me. The data's dirty. And as we start to get into these air quality things, and you're looking at data, all data's dirty. So you kind of have to look at it and say, what's reasonable? What am I going to do? Maybe I'd take an average of these two for a particular day. That'd be really, really easy for us to do, and just take an average. So, any questions on this?
In the case of the missing data, we'll fill with, it's possible to fill that data with.
Depends on what you're trying to do, what kind of model. So maybe a null value would be appropriate. Maybe a 0 value would be appropriate. I think it just depends on the question you're asking, and the model that you're building is what you use to fill it. But no data is no data, and maybe
for the purpose of the competition, though, what's an acceptable way you can interpolate, or you can put null.
Well, I don't know. That's what I'm saying. I'm actually pushing the answer to what are you trying to solve? Because I think there are different ways to. You kind of have to have a little understanding of maybe if I put in a 0, that means like for a temperature. If I put in 0 for a missing day's worth of data, 0 is a valid temperature. Even -1, which we often use, is a valid temperature. So it could throw off your model altogether. Maybe a null is more appropriate there, which here is a missing value.
So,
Yeah.
So I was going to say on the air quality side for the competition, the way we'll probably treat it is, as you clean the data sets, what anomalies you find, you should document them. So that when the data set is returned and it says, I removed X, Y, and Z because of these anomalies. So that way, whoever looks at it then knows exactly what was done to it. And if there is a question on, should I remove, should I turn it into null or something like that, that's where we bring in the experts and ask, okay, what needs to be done?
And that's more of what I was leading the question. I mean, if people are cleaning it, you can obviously interpret what you might want to do, but then that could throw the data set for the whole competition off too.
Yeah.
So
I think the key things is document what you found, so that we can ask the experts, what would you do in this case? What is the best practices for that? Because we don't know, and that's one of the key parts of this. We don't know the data perfectly. We want them to know.
We can also go start trying to find other sources for the data, like UHUG has sensors, and so now maybe we can pick it up from them instead of the EPA.
Yeah.
So on and so forth.
So,
and it might be an outcome too that like there aren't enough like granularity in the data sets where we can take that back as feedback to the state in the future as well. Possibly.
Yep.
Yeah. Although when it comes to the air sensors, I have no concern about it.
So,
What I saw yesterday.
so here's what I would actually recommend for the competition. The phase 1 of data collection, we are documenting what we're finding. We're not filling in the blanks, right? Let that be a later step when you are actually asking the question that you're trying to solve. Do a last-minute eval, fill in the blank, and solve it there. For one team, it may be one value. Another team, it may be something else. So it could be completely different. So.
Yeah, I think the key there is always the same with any data set. Know what you filled it in with to be able to explain that.
Yeah.
If you talk to a business or something else and they have invalid data, there's some sort of business rule that handles that invalid data. This is the same thing. There will be some sort of rule that says we need to do this when Y shows up.
So where's Hawthorne? I know where Rose Park is, but I'm kind of curious because some days those had some pretty drastic differences from each other.
I couldn't
Anybody
tell
know where
you.
Hawthorne is? That's on
There's a Hawthorne school near Liberty.
Maybe that's probably
Park.
what it
That's
is.
it. Yeah.
That's not very far. Liberty Park to Rose Park. That's
It's about a mile difference, if that.
Those places where all of those refineries.
It is. It's closer to the north side.
That's probably low.
But yeah, I mean, the Hawthorne levels were higher in some cases.
yeah.
Hawthorne's not far from 215. Yeah, it's about 7.
Yeah.
East.
Liberty.
There's a fair bit of traffic.
There is.
So it might be interesting. We might see Rose Park is specific to refineries, and Hawthorne is specific to car traffic. That would be really cool. Oh yeah.
Okay. Okay. Thanks for sticking with me. Last thing, I promise. Another reason why Pig is awesome. It's sexy again. Lipstick. All right. I didn't do this logo. You can thank Netflix for it. This is what it is. What it is, it kind of hooks in. So when pig executes, it actually fires off events through hooks into Lipstick. I was able to actually get it to run as a Tomcat app before, which made it really, really powerful for our entire dev team. Just fire it up, throw it on the server somewhere, or throw it on the server somewhere, fire it up, and then you could go in and you could execute. For my VM, I did version 5 of Cloudera, and for whatever reason, there's a jar conflict, a class path conflict. So I can't throw it in Tomcat, but I can show you running in debug mode. So what it does, it's got a really cool thing where I can actually visualize what's going on in the code, in the execution. There we go. So unoptimized doesn't work in this version, so I can't show you that, but optimized, I can show you all the optimizations that it's making. Is that semi-readable?
Awesome thing I've ever seen.
Yeah, so take a look at that. I mean, what information does that give you? I'm reading from a CSV file using Excel storage. This is a loader function in Pig, and I'm storing it in a variable named data. Okay? I read in 3,527 records. I'm going to go over those, and this is my next statement. I'm going to do a for each. I'm going to generate slim data. Slim data is something I do. It's just a common word I use for projecting. I'm going to shrink it down a little bit. Instead of that huge schema, I'm only going to pull out the ones I want. It gives me the field names and then the data types. Internally, it's going to do a split because I'm going to move the data around. This is completely, I just crafted this. This is nonsensical, this data flow here, but just kind of shows you what it can do. I'm going to split the output where the city name is Magna and the city name is Logan. And I'm going to create 2 new variables. Now, the blue indicates here that it was done in a map phase. So it gives you a lot of clues to what it's doing. Here, when I said it's really cool to actually look at the data, I can click on this and I can actually see sample data as it's flowing through the various steps. And I can see that, I've got a date, in the Yoda time format. It's got strings and everything is looking fairly ordered here. Same thing over here if I want to do that. Sometimes these numbers are a little off in the transition phases, just as a little warning. But as a whole, they're actually really good. These numbers I trust within the big blocks. So I wanted to show you something really cool. So I said for the Magna data, let's actually split. So I created, I'll show you, you guys can look at the code here, but I actually took the same data source. I did 2 projections against that. So I have one that has 3 fields, another one that has 4 fields off the same original data set. And I'm going to go over those things, and I'm actually going to join it back on itself. Again, it's nonsensical. I don't know why in the world you do this in real life, but you can see it's doing a join. Taking Magna data 2 and Magna data, and I'm going to join on the field date local. And then I'm going to do a projection. Because I have 2 joins, my schema has now gotten very, very large, and I have a lot of duplicate information. I want to shrink it back down. So this is the projection that's going on. And I have 116 output. See, that's what it looks like. So really cool. Then, because I wanted to actually do a union, I want to actually shove everything back together. You can see there's another MapReduce cycle that happens. I'm going to do a union operation, and then I'm going to actually store it into the out file using pig storage. Now, that's really cool. Now, the other really cool thing, as this thing is executing, I won't show you because it'll take a long time, these little squares start to flash where it's actually executing. So you can see what's happening in real time. Now, this thing, these little job identifiers, will tell you how to get back to the scheduler. So this particular scheduler, I'm using Yarn. Yarn's a another resource tool. It's the next generation. So I have nothing running now, but I can get in there, see all the jobs that I've run in Yarn, go to the history, and succeeded. Get to the logs. I can see all the mappers and reducers and so forth. Here, I can actually see the duration, so I can start to eyeball what's taking time and maybe something that I need to go investigate. Sure, you could do that going to the scheduler, maybe have some other custom code that you built to pull data out of the scheduler. But this makes it really, really easy to see, okay, this particular step took, maybe it took 2 hours to run. Maybe that's something I need to go look at. But I don't know what that step is, so if I start to click on these things, it's like a drill down. It filters in and gives me the job ID, how many mappers, reducers, gives you all the counters that you know and love, file system counters, output counters, all that. And finally, the other thing that you can do is here, let me actually get to somewhere, kind of losing the real estate here on the screen. I can figure out, there we go. I can go back into the original pig code and I can see what was the pig statement that was being executed in this mapper reduce cycle. Really powerful. So again, I've seen this save. This is one of the tools we use to go from that 2-week cluster time down to 28 hours. We really drill down, start to see some of the pig functions that were misbehaving, weren't working well in conjunction. We converted them to Java UDFs, and life is great. So, any questions on that?
So it's a standalone Tomcat against your Hadoop?
Yeah, so the question was, is it a standalone Tomcat against Hadoop? This is, right now it's a Grails application, so it builds to a WAR file. In a perfect world, you could deploy that to Tomcat. I can't get it to work with this version because of jar conflicts, but I'm running it in debug mode, so it fired up I think it's I can't tell, maybe a Jetty server, and it's just running. So it stores everything in a MySQL database. Go back and you can do root cause analysis later on, and so forth. So I can show you that the Netflix site is there. What I did to try and make your life easy. If you happen to use CDH has a couple quirks to it. They're a little bit different than vanilla Hadoop. These are the changed files. You can get in there and just copy them. So when you do your build, this does a typical Maven build. It will pull down the right versions of things and yeah. Anything else? Okay, question.
So we always hear that like pig in turn converts into MapReduce, right?
Yes.
Is there anyone like made an attempt to capture that MapReduce?
Okay. So the question was yeah, it's a great question. The question was pig internally converts everything to MapReduce. Has anyone had any attempts to capture what that MapReduce was? So maybe you want to tweak it in Java, pure Java, right? Last time I asked that to some of the committers, they say that it's so complicated on the internals, don't bother. I haven't seen a way. That's not to say it's not possible, but they don't expose it. So last time I heard it's not possible. And conversely, or not conversely, but in addition to that, I would really ask why. If you spend the time and you can build it in Pig, oftentimes your time is more valuable building Pig code and moving to the next problem to solve than getting that last 2-3% of performance. Cluster time is way cheaper than a team of developers. Yes?
So, question I just came up with, is there anything that shows you, from like an operational perspective, when the node's about to OOM because of telemetry stays or anything like that?
So the question was, from an operational perspective, is there anything that can show you when a node's going to OOM or anything like that? Part of vanilla Hadoop, there are all sorts of tools being built out there to do that. I can show you with what I did in my VM using Cloudera, because it's the easy. I have an unhealthy system, but what they do is, you can see, I have all the placeholders for all the charts. I can start to see when all the nodes are going to, the CPU is going way up. I can see when the JVMs is going way up. I can see when network traffic is spiking. Maybe a common thing that you got to worry about when you're sizing a cluster: are you CPU bound or are you IO bound? And those are very different problems to solve. Anything Ganglia will give you the same type of information. They just happen to put it all in here and give you the alerting too.
So is it query specific? Can you find and kill the query that's doing it?
So the question is it query specific? Using this tool, no. But what I would do, it's actually really easy to do, using the Yarn scheduler. This is not specific to Cloudera. I can see here, relatively, you can see I've got different queues, the MAC queue and the default queue. I can see who's consuming all the resources. Additionally, up here, since Yarn is dynamic in terms of CPU and memory utilization, I can say, oh, wow, Matt is consuming all the memory on these clusters. So maybe I need to throttle him or put him in a different resource pool, so he doesn't do that. So this is a very, very powerful tool that's available for everything. Anything that connects to Yarn can take advantage of this, because this is the scheduler. Anything else? So thanks for your time, everyone. I hope you go out and you try Pig. The examples I showed you tonight, I'm going to be forthcoming. Pig is not the tool to solve air quality monthly data. It's way overkill. The infrastructure required to look at 100,000 lines of data is probably, you could write it faster in Java or Python or anything like that. Where it excels is I have a business process where things don't fit in memory on a single machine. Okay, so go back to my example earlier of the graph that had hundreds of millions of vertices and tens of billions of edges. That will not fit in main memory. That's a perfect thing for a Pig or MapReduce type thing to do. There are also specific graph databases that are actually even faster. But Pig is my go-to for anything that requires any real crunching, anything that I want to support long-term, because there's all sorts of tooling built around all the things that you use internal to Pig, the continuous integration, the Java, any existing libraries. I can reuse investment that's already been put out there. I can do the same thing in Hive, but I just prefer Pig because it solves more of the problem for what I want to do. So, yeah, thank you. Did you have a question, Logan? No? Okay.
All right, you're welcome to grab some more pizza and stuff. We'll be hanging around for a little bit longer. Feel free to chat. Like I said, there's lots of pizza. Come up and talk to Matt or any of us.
So the new stuff,
I'm trying to figure out where it is.
it's back. It's on the second Windows machine.